Hi everybody, so today we're going to be going over an example of how to basically construct an equilateral triangle using the program robo-compass. So what I have here is basically, a prompt that, we could get, and I think what your assignment is going to be for your exit ticket for today's asynchronous day is basically just going to be exactly this, just these 2 points will be different. So instead of 2, 4 and 10, -3, you'll have two different sets. But you're going to have to basically come up with this process yourself. And either way, that if you program it correctly, then you should be able to input whatever points you have, and it should still work for an equilateral triangle. So I want to walk you through the process for this. So if you open up robo-compass, I'm going to post a link for it in Google Classroom, but it's up here if for whatever reason you want to type that in instead. Let's just look at what our assigned points were. So our points were 2, 4 and 10, -3. And remember what an equilateral triangle is it's a triangle where every side is the same, every angle is the same. So that's kind of what we're trying to do here. So I'm going to go ahead and label my points A and B. I'm going to say that A is equal to, and basically you can use this kind of as your model. The way you program this is, if we want to put a point on the graph, we just say that A is the point. Our point was, they give you like an example here that can kind of help you out. Our point was, what was it, 2, 4? Yeah, 2, 4 is our first point. And just like that, the point 2, 4 is plotted, go over 2, up 4. The next point I'm going to plot is, I'm just going to label it B. And technically you can call these whatever you want. I'm calling it A and B, but you could call it something different if you wanted to. What's important is that you're able to get it onto this grid. Next one was 10, -3. And then there's B down there. So what I want to do is I want to construct an equilateral triangle using those 2 points. And yeah. So we have these 2 points here. What we want to do is we want to find, where is that third point going to be to make this an equilateral triangle. If you were to kind of think about it, it would probably be somewhere over here or somewhere over here, and then you'd have the triangle so that every side is the same. But we have to do this very precisely. We can't just guess. So the way you start this off is first you have to make a line. So the first step is just to connect those 2 points. So I'm going to say that this. I'm just going to call it line LN AB. So line AB is just going to be equal to, and the reason I'm doing this, I'm just giving it a name. In programming, you often want to give a name just to describe the process you're doing. So if I want this to be on my picture, I want to be able to refer to it later. So I'm going to say the line AB is equal to a line from those 2 points. And what it here says here is I could actually input, x1, y1, x2, y2. What you can actually do is, since we defined A and B here, we can just use those 2 points. So I'm going to say A and B. Once I close that, it makes that line. So we know a triangle is a 3-sided figure. So we have one of our sides now. And we have 2 points, we need a third point. So what I'm going to do now is, for a construction, we're going to use our compass. So I'm going to make a circle around A. So I'm just going to say, so for this one, we're going to use the function arc. And actually, I'm going to call our circle something. So you always want to give it a name. So I'm going to call it circle around A. I'm going to call it CA is equal to. It's going to be the circle around A. So I'm going to say it is an arc. And it actually kind of helps you out here. It shows you a way to basically define this. Point 1 is going to be, your point 1 and your point 2, that's basically the length of your arc. So I want my circle to be around A and B. So using A as the center, and B is like, the distance from A to B will be my radius. So I'm going to say A is my first point, B is my second point, and then my origin point, we want to go around A. So I'm going to repeat A. And then, and I'm just kind of looking here. I'm using this bottom one. because I actually don't know exactly what the distance is from A to B, because it's not along a grid perfectly. I think we need to do Pythagorean theorem to actually figure this out, what the distance is. But what I'm just going to do is I'm just going to say, well, our radius is the distance from A to B. That's kind of what we're saying here. So we do that. Now our angle from, angle up to, if I want to make a full circle, I'm just going to say it goes from 0 to 360. You don't actually have to make a full circle, but if you do, it'll just kind of make the process I think a little bit easier. So we make the full circle. That's the way I'm going to do it. So I have a full circle here, and what we're going to do now is we have to make another circle. And where those two circles intersect, that should be where our third point will be. So we made a circle around A. Next step is to make a circle around B. So the circle around B is going to be equal to, again, we're going to use this arc function. Our 2 points are A, B, but now our origin point is different. The origin is basically the center of your circle. Now we're making it around B. So I'm going to say A, comma, B, comma, B, and then I'm going to make a full circle again. So I'm just going to say 0 to 360. Now what I have is I've got two intersection points here. My circle, this one's not actually on the screen, but you guys can see it there a little bit, hopefully. Okay, so we have two intersection points. We just got to try and make sure we get the right one in there. So this point and this point are both potential points to use for equilateral triangle. I'll be fine with either. So let's just say what I'm going to do now is I'm just going to try and drop that point down here. So basically the steps of the process are we started with drawing our line. We made a circle around A with radius AB. Then we made a circle around B with radius AB. And now we have these 2 points that intersect. Either one of them can be our third point of the triangle. So that point I'm going to call it C. I'm going to say that C is going to be equal to basically that point of intersection. So for when you're programming in robo-compass, you can say intersect. Well, actually, so C will be a point. That's the first thing you can say. It's going to be a point, and it's going to be a point of intersection. I'm going to say intersect of those two circles. So our two circles were circle around B and our circle around A. So actually it's got to be like this. Circle around B, circle around A, and then that's where our third point is. And it could have just as easily popped one down here. I think either way it'll make an equilateral triangle. So now we have our third point. To make our triangle, we just have to connect these points. So I'm just going to say line AC is equal to the line from A to C. Got that there. Let's just make one more. Line BC is going to be equal to the line from B to C. Close that. Now we should have an equilateral triangle. One thing you can do over here is you can click on the view. If you want to make this two-dimensional, I think that makes it look closer to equilateral triangle. Basically what this means is, this side, and this side are all equal. This angle, ABC, is equal to angle BCA is equal to angle CAB. So all these angles are the same. Every angle will be 60 because it's an equilateral triangle. So, and just so you guys know, if you wanted to see another example of this, I have this example right here. You could go over to examples and then hit an equilateral triangle. You can watch that yourself if you want to see if it's done a little bit differently. It's more professionally done, but I think what I want you guys to do is something a little bit more like this. At least that's a little bit more straightforward. So last thing I think is just how do you save your work and prove that you turn this in. Again, I'm going to be giving you some sort of different points here. So, but either way, the process will be pretty much exactly the same. I just want you to go through that process and just kind of practice using robo-compass. What I would do is go ahead and take a screenshot of this, and you'll send me that screenshot, or you can use your cell phone and take a photo of your screen. Either way is fine with me. So like for me, what I would do is I would use snipping tool, and I would just, grab a screenshot of this. And this is something I could turn in. But you can take a screenshot using, I have snipping tool. You probably have a different way to take a screenshot. If you don't want to do that, you can just take a picture of it on your phone, and you can upload that onto Google Classroom. Just make sure you turn this in. That'll be how you get your credit for this Wednesday. Make sure that you comment on the stream that you are here so I can mark you present, and also do, the do now and the SEL activity. So that's all I have for you. Just trying to, go through this programming process. I think I walked through all the steps. So once, you've done this, you'll be a little bit more familiar with the program, and, we can use this to do more advanced stuff in the future. So if you have a good rest of your Wednesday.